All right, so you can skip this video if you're not interested in seeing why something is happening. If you just want to memorize it, you can just go ahead and watch the second video here. I'm going to try to explain uh, why something is happening. So first, what we're going to do is go back to something that you learned in geometry. It was about the 30, 60, 90 triangle. So we're going to start with an equilateral triangle. So all of these angles are 60 degrees. And what I'm going to do is I'm going to drop an altitude down that kind of divides it in half. So this angle right here is going to be 30 degrees now. And this one's going to be 60. And of course, this one's going to be 90. And let me see if I can. No, I can't do that, but that's okay. Now let's label the original side length. I'm going to label that X. Now because we cut it in half, this means that the shortest side here is going to be 1/2 X. All right, 1/2 X. Let's go ahead and solve for this this height right here, H. So we can do that using Pythagorean theorem. We've got H squared plus 1/2 X squared is equal to X squared. All right, let's simplify this a little. H squared plus 1/2 X times 1/2 X is 1/4 X squared, and that's still equal to X squared. Let's subtract this one from both sides. So we have 1x squared, and we're going to minus 1/4 X squared. Okay, H squared is equal to, well, 1 whole minus 1/4 is going to be 3/4 X squared. All right, and then we're going to square root both sides. So that'll give us H is equal to the square root of 3/4 X squared. All right, we can go ahead and simplify this a little bit. The X squared is going to come out as an X. And let's see here. The 4, so the 4 is, it's like, I'm just ignoring the 3 for a second. So you've got a 4 in the denominator. So when you pull that out of the square root, it's just going to be a 1/2. Actually, yeah, let me do 1/2 on the outside. There's an X on the outside. And that square root of 3 is still going to be left on the inside of the radical. All right. So now the height we can express in terms of X. So this height is going to be 1/2 X root 3. Now, this is a really bad way of expressing this triangle. So what I'm going to do, and you'll see that it does work when you go to talk about ratios and similar triangles. But what I'm going to do is I'm going to choose a nice value for X, and it's going to make this whole thing look a lot nicer. So I'm going to go ahead and redraw just that part of the triangle that I need. So I had X, this was 1/2 X, and then this one was 1/2 X, 1/2 X, root 3. All right, so what I'm going to do is I'm going to choose X equal 2 and just plug that into the triangle, and it's going to be a true triangle. So if I know that these are 60 degrees and 30 degrees, then any number that I choose for X is going to complete this triangle. It's going to make it real side lengths. So if I choose 2 for X, what you're going to get is a 2 for the hypotenuse. Here, if you plug in 2 for X, that's 1/2 of 2. That's just going to give you a 1. And here, if you plug in 2, you get a 1/2 of 2, which becomes 1 root 3, or just root 3. All right, and this is a 60-degree angle there, and that's a 30-degree angle here. So this right here, this is it's a ratio. It's a lot of times, like in geometry, this will be the setup that you see as far as what they call a 30, 60, 90 triangle. And the way that they use it is, let's say you know that you're dealing with a 30, 60, 90. Well, if you know that this hypotenuse is equal to 5, then you can figure out the other pieces. You would know that the one down here is going to be exactly half of 5, so it'd be like 2.5. And then you would also know the missing leg here. You could use Pythagorean theorem to figure it out, but it ends up being some ratio of the 5. It ends up being, you can think of it in terms of that 5. It would actually be 5 over 2 root 3. All right. So this is going to be the main part that we're going to use. We're going to use this to define our trig functions.